Very good morning to all of you. Let's start with the next question of your questions based on principle of homogeneity. Today I will be discussing the different varieties which were left in our last videos. So आपका क्वेश्चन है आज आपको इक्वेशन गिवन है mu equals to a plus b upon lambda square. यहाँ पर this symbol is your refractive index. Okay. In class 10th you have seen the symbol of refractive index as n. Okay, but there are two types of symbol for refractive index, n and your mu. Okay, it's just like your u symbol. Okay, so these two symbols are worldwide known for refractive index. Okay, so any symbol can be there in the question, so you must be ready for the both. So here this symbol here is representing refractive index. Now this is your a, this is your b, and this is your lambda. Lambda means wavelength. Now we know the dimension formula for refractive index. We know refractive index is the ratio of speed of light to the speed of light in medium. So speed of light divided by speed of light, so no dimension will be there. Okay, so dimension formula for refractive index is m0 l0 t0. Now wavelength we know is the distance between two consecutive crust or trough. So it is the distance means dimension formula will be L. Okay, this one. Now the question he is asking you is find the dimensions of A and B. So you need to calculate the dimension of A and dimension of B. Okay, now let's start with our solution. Now look, this formula is given to us, it means this formula is correct, and principle of homogeneity says that if a formula is correct, then dimensions on left hand side should be equal to dimensions of right hand side. So look, on left hand side we have refractive index. When we move on to the right hand side we get A, हमें A मिलता है. Now according to principle of homogeneity, whatever is the dimension of this should be equal to the dimension of A. So by principle of homogeneity, dimension of A should be equal to dimension of mu, that is your refractive index. Okay, now when I move further I found a sign plus, मुझे plus मिलता है, and after the plus we have b upon lambda square. Now again according to principle of homogeneity we know only same dimensions can be added or subtracted. Now here A is getting added to b upon lambda square, and both can be added only if they have same dimension formula. So whatever is the dimension of A should be the dimension of b upon lambda square, and the dimension of A we just calculated is equal to mu. So the dimension of b upon lambda square will also be equal to refractive index. Okay, so keep that in mind. Here left hand side we have refractive index. When I move on to the right hand side I get A. Okay, now whatever is the dimension of this should be equal to this according to principle of homogeneity. I have written that. Now after that when I move further I get plus sign, and after plus I have b upon lambda square, and we know only same dimension can be added or subtracted. Okay, so both the dimension should be same. It means b upon lambda square should have dimension equal to A, and dimension of A we already know is mu. So the dimension of b upon lambda square will also be equal to mu. Now let's solve it. Now dimension formula of mu is dimensionless, so A will also be equal to dimensionless, m0, l0 and t0. Now here let's calculate here from here. B we need to calculate, and wavelength dimension is L, and wavelength square will be L square, and here on right hand side is m0, l0, t0. Now for calculating B we'll cross multiply. Okay, now look, this is dimensionless, so we can neglect it. Here we have L square, so it will come as it is. So the dimension formula of B will be equal to L square, and dimension formula for A is equal to m0, l0, t0, that is dimensionless. Okay, so here also we have make use of our principle of homogeneity. Now let's move on to the next question of today. Now let's discuss our next question of today. A equation is given to you, p plus a divided by v square multiplication में b minus b is equal to rt. This is your van der Waal equation. Van der Waal equation you will be studying in chemistry, this one. Okay, so here we will be calculating the dimensions of a and b from this equation. Okay, now here p is given to you pressure. Pressure dimension we know is force by area, ml minus 1 t minus 2. Volume is L cube. T is your temperature over here. Temperature dimension formula is K. Okay, its unit K na. From there we have same dimension formula K. Okay, now gas, this R is your gas constant. Now what is this gas constant? Look, in your chemistry and in your physics, in physics we'll be having our unit ninth unit, we'll be studying all these gas constant vagera, and there will be dealing with the gases. There will be having two types of these equation. PV equals to nRT. This is your ideal gas equation. We'll be studying in ninth unit. And this is your kinetic energy equal to 3 by 2 times of RT. There, this R is your gas constant. So if you want to calculate the dimension, I prefer this one. Kinetic energy equal to 3 by 2 times RT. This is for ideal gas of 1 mole. Okay, mole you know, in chemistry first chapter you have already studied that. So this is the kinetic energy of 1 mole of gas. Okay, 1 mole of ideal gas. So this is very easy to calculate from here, this formula. You can easily calculate the dimension of gas constant. So don't prefer this one, prefer this one. Okay, so I prefer this one. So R will be equal to kinetic energy divided by T. Kinetic energy means energy, ml to T minus 2. Work done K equal. And T is your temperature. So you got the dimension formula for gas constant is ml to T minus 2 K minus 1. So if you want to calculate, whenever you want to calculate, always prefer this one. This is very easy as comparable to this one. Okay, from here you can easily calculate the dimension formula for gas constant. Now let's come on to our question again. Now we know all the dimension formula for all the physical quantity. Now question is given to us this, we need to calculate the dimension of formula of A and B. Now look, you'll feel surprised that we don't need the dimension formula of R and T over here. That's of no use. We can, without the use of this, calculate the dimension formula A and B. So sir, what's the use of calculating the dimension formula R? So this is beneficial for you from the exam competition point of view. There you will be needing it. So that's why I have explained this also over here. But in this question, I don't require R and T, because look, principle of homogeneity has opened the gate for us. This question, principle of homogeneity has make very easy, because principle of homogeneity says one most important thing, that only same dimensions can be added or subtracted, and that line, that statement given by principle of homogeneity makes this question very easy. Look how I am writing the equation again. Now look over here. In this bracket you have, this is pressure plus A upon V square. Now we know only same dimensions can be added or subtracted. So whatever is the dimension of pressure should be equal to the dimension of A divided by V square. Look in this bracket, we have V minus B. So whatever is the dimension of V should be equal to the dimension of B, because only same dimensions can be added or subtracted. So we don't require this RT for solving this question. So according to principle of homogeneity, only same dimensions can be added or subtracted. We know this. Okay, therefore whatever is the dimension of P should be equal to A upon B square, and whatever is the dimension of V should be equal to B. So dimension of B will be equal to V. Okay, now let's calculate the dimension formula for A and B. Now let's solve this. Dimension formula of A we need to calculate. This is your volume. The dimension formula for volume is L cube, and here it is square. So when you will do this, be very careful. Volume is L cube and the power is square too. So sometimes students write over here this one, and this is wrong. You don't have to square this up. Don't do the square of 3 over here. In fact, it is equal to L cube into L cube. Just be very careful. The meaning of this is this one. Be very careful about that. It is the square of this L cube. So L cube you have to write twice. And it will be equal to L6. Okay, so be very careful about this. Student usually commit this mistake. So our correct answer is this. So here you will write L6. Pressure is ml minus 1, T minus 2. Okay. Now let's cross multiply it. We will get our answer. Okay. ml minus 1, T minus 2 multiply with L6. So you will get L minus 1, L6, you will get L5 and T minus 2 as it is. So the dimension formula for A is equal to L5 T minus 2. Now let's calculate for B, and B is very easy to calculate because V is equal to L cube. Directly put that. So the dimension formula of B is L cube. So look, the equation looks very scary to us. What is this equation? How we are going to calculate A and B? But look, the solution is very easy. Principle of homogeneity has made this easy for us. Okay, just keep in mind only same dimension formula, dimensions can be added or subtracted. So whatever is the dimension of P should be equal to the dimension of A upon V square, because both are adding up. Here these both two are getting subtracted from each other. So only same dimensions can be added or subtracted. So whatever is the dimension of V should be equal to D, that I have written over here. And using that you can easily calculate your dimension formula. Okay. Now let's move on to the next question of today. Now let's discuss the next question. Now the question here is find dimensions of A multiply B divided by C. This one you need to calculate over here. Okay. Now this is a different question, a slightly different variety of questions on principle of homogeneity. Look over here, we have trigonometric ratios with us, and whenever trigonometric ratios come into play, then we have to change our style a little bit. Okay. Now equation is given to us, y equals to 4 sine 80 plus 3 cos bt minus ct. Here your y is distance, dimension formula is n. T is your time, dimension formula is t. We know it. Question is, we need to calculate the dimensions of A multiplied B divided by C. So what we have to do here, first we will calculate the dimension of A, B and C. Then we will put in this A into B divided by C. Then we will get our answer. Now our focus is to calculate A, B and C first. So how we are going to deal it? So our approach is slightly different here. So don't go for the usual approach here, that whatever is the dimension on left should be equal to the dimension on right, and you start comparing sine 80 with L. Don't do that thing. Okay. Here it is something different that I am going to tell you. Now see this. Let's start with the question. Okay. Now look. Here it is given to you sine 80 cos bt. Whenever trigonometric ratios are involved, just keep one thing in mind. Whether you have sine, cos, tangent, anything, whatever is with this sine, cos, tangent, that is your angle. Okay. Because trigonometric ratios, they carry angle with them. So whatever this 80 is given to us, this is comparable to angle theta. Okay, just keep that in mind. If you know this small step, this small thing, then you can easily do the questions of your trigonometric ratios. So keep that in mind. Here with sine I have 80, and I have already told you sine always carry angle with it, cos always carry angle with it, tangent always carry angle with it. It means this 80 is equal to your angle, and the dimension formula of angle is dimensionless. You know it. Dimension formula for angle is dimensionless. Angle is that physical quantity which is dimensionless, but it has unit, radian. Just keep that in mind. Okay. So let's start with the question. As we know, so here we know that sine 80, this 80 is comparable to theta. So we can write here AT is equal to theta. Our BT, this is equal to theta only, because BT and AT, they are with sine and cos, and sine and cos always carry angle with them. So these are comparable to each other. Now what left? CT left. So for this we can use our usual method, conventional method of principle of homogeneity. Whatever is the dimension on left hand side should be equal to right hand side. So left hand side we have y, so right hand side should also be equal to y. So using principle of homogeneity, our CT will be equal to y. Now we can solve this and we can have our answer. So be very careful whenever your trigonometric ratios are involved. So trigonometric ratios carry angle with them. So this AT and BT will be equal to theta. Now let's solve this. So AT, and here right hand side you have dimensionless M0, L0, T0. Angle is dimensionless. So A will be equal to your T minus 1. So we have got the dimension formula for A. Now let's calculate for B. Now B is the time, angle is dimensionless. And look, whatever happens, never forget this square bracket, because without that we are not dealing with dimension formula. Okay, so be very careful regarding square bracket. So B will be equal to again T minus 1. Now let's calculate C. C, here is your time, it's your length. So C you will get L. So C is equal to LT minus 1. But here we don't have to calculate ABC. Our target is A into B divided by C. So let's calculate that. So A multiply B divided by C. A is equal to T minus 1. B is equal to T minus 1. And C is equal to LT minus 1. Okay. Now look over here. This T minus 1, this T minus 1 will cancel out. So this L, when it will go in the numerator, it becomes L minus 1. And T minus 1 we already have over here. So our final result of A multiply B divided by C is equal to L minus 1 and T minus 1. So today I have discussed 3 more varieties of question based on principle of homogeneity. Look, this type, this question based on principle of homogeneity, they are very important from the school plus your competition point of view. Usually one question for sure you are going to get from here. Okay, so keep practicing them. In next video I'll be taking your more questions from the dimension analysis. So I'll see you in the next video. Till then, keep revising and stay fit. Thank you and have a nice day.